Hello everyone, this is our team called Crusaders from the Rajlakshmi Institute of Technology, and I am Jayantan SV representing the team. Our problem statement for SIH 2023 is to analyze an identification of malicious mobile application. The problem statement is basically from the Ministry of Power based on the theme of blockchain and cybersecurity. As the Android market continues to expand, obviously malicious application grows simultaneously. According to the ZDNet, 10 to 25% apps are available on the Play Store which could be malicious in nature. These apps may innocent at first glance, but they break on the user system in a variety of harmful ways. Unfortunately, the current method for detecting the malicious applications are both resource intensive and exhaustive. They struggle to keep up with the rapid pace at which new malware is being developed. Our goal is to build a machine learning model that can accurately predict whether an Android app is malware or not. A trained machine learning model that can classify Android apps malware are winning with high accuracy. A Kaggle dataset was used for the dataset. The data includes information on the permissions of nearly 30,000 apps. The dataset contains nearly 183 characteristics such as danger, permission count, access DRM material, transfer application resource, etc. There is a single binary target class named class that designates a winning binary 0 and malicious binary 1. These are that there are the 30,000 records, nearly 10,000 are good programs and 20,000 are malware application. Initially with the data set, we are going to pre-process, visualize and analyze. The data is first imported from the CSV file and loaded into the data frame by these for user. The necessary attributes are then extracted from the data set. To gain a better understanding of data, several plots are generated. The data is checked for the null or missing values, and any such values are replaced with the mean of corresponding column. The distribution of the malware and the winning application across the various settings is then analyzed, and the results are visualized through a series of plots created using the matplot and Seaborn. The explanatory data analysis EDA for the data permission data set provide valuable insights into relationship between the different features in the data set and helps us to identify the most important feature for predicting the app rating. It also provided a foundation for the further analysis using the machine learning techniques. After the pre-processing the data, it is split into the testing and the training sets at an 8.2 ratio. We attempted both under and over sampling techniques on the data set, but the results were not promising. We then applied various classifiers including the logistic regression, decision tree, maybe built, but the outcomes were not unsatisfactory. Upon the further inspection of the data set, we have discovered that it contains several multivariate data tables which required us to apply PCA to each data set. We plotted the various permissions percentage after using the PCA. We choose the inverse transformation. We apply random forest to the data set, which resulted in the significant improvement in accuracy. The results showed that model was improving. Finally, we applied SVM and MLP to final data set and achieved our best. We comparing the results obtained after the feature selection and boosting, we can see that I have made significant progress and achieved a final accuracy. Accuracy follows as an order. Decision tree, which is better than the logistic regression, which is better than the Gaussian naive Bayes. The classification done by various models are shown in the table. Looking at the result, we can say that random forest performed the best among all the classifiers of accuracy of 86%. As we seen in the tabulation, that accuracy follows as order of random forest greater than the MLP greater than the SVM. Analysis will help you to understand the use cases such as threat detection and alerting, behavior analysis and risk assessment, app quarantine and removal, real-time network monitoring, threat intelligence and updates, user education and best practices, privacy compliance, and then business adaptation and partnerships. After the result and analysis, it will give us the significant impact such as better detection, real-time protection, fewer false positives, better user experience, improved security, and future research and development. For certain limitations, these detections have some potential stoppers such as legal and compliant issues, data security and breaches, research constraints, and user trust and adaptation. at last competitive landscape. Finally, these analyses were coordinated and executed by our team members Tejit Thomas from the third year CSC, Bharat P from the third year CSC, Ashavardhan from the third year AIDS, Sujit from the second year AML, and then Mary Suja from the second year AML. Thank you.